Hello everybody and welcome. Let's continue programming in OpenGL. We've now created the ability to send vertex data in world or screen space instead of normalized device coordinate space and do that transform inside the vertex shader. And we've also looked at a way for sending uniform data to the shader as well. In this case, we're sending the viewport data to the shader so it can do the transform. Today what I'd like to do is actually implement a custom vertex type, or provide the ability for us to make a custom vertex type that is reusable and very user-friendly and readable. Right now, if we go back to our code, all of our vertex data is being provided in this vertex array, and it's just a series of floating point values that just come one after another. What I'd like to do is, instead of just having floating point values, let's make a structure that is a vertex. And the vertex is going to contain all of this information. It'll contain a position, it'll contain a color, and then it can contain actually anything we want it to contain. It'll be very customizable, and it'll contain all the information a vertex needs to know about OpenGL and about vertex attributes. So the vertex type itself can actually send the data to the vertex array. So this vertex array here, we won't have to do this setup code every time. We can just tell the vertex array what kind of vertex this is, and it'll automatically populate all of the VertexAttribute pointer information. So this is going to make things very reusable, much more simplified, and very readable. So over here, I'm going to actually, inside of our project, I'm going to add a new class. And I'm going to call this Vertex Definitions. Okay, and we're not actually going to have a class called Vertex Definitions. This is just where all my vertex definitions are going to reside. And so all of our vertices are going to be structures, and they're going to be read-only structures. And I'm just going to give these a name. So this one's going to be vertex position and color. And the name is going to indicate what kind of attributes it has. So this vertex is going to have a position attribute, and it's going to have a color attribute. Let me bring in the OpenTK mathematics. We're going to need to provide it some vectors and some colors. And so I'm going to use the OpenTK mathematics to get access to those structures. Okay, so the first field is going to be a public vector2, and this is going to be position. And then the next one is going to be a color, actually a color 4, and we're just going to call that color. Okay, so we have our two vertex attributes, which is the position and the color. And you'll notice I'm defining this as a vector 2. So we're proceeding now with the intent of making this a two-dimensional game programming framework, or a framework where we can easily and rapidly create two-dimensional games in OpenTK without having to do all of the OpenTK and OpenGL low-level code. We can just use our high-level framework and get into programming really quickly and efficiently. Okay, but I'm using vector 2s here, and if we go back to the game class, we were providing 3 floats for position, an x and a y and a z, but I'm actually not going to do that anymore. We're going to set this up to use 2 floating points, an x and a y. And so we're going to have to not only change this, our array here, but we'll also have to change the vertex shader because it takes a vector 3. But that'll be a really simple change, and we'll do that here in just a second. Let's go ahead and set up our vertex first. Okay, and so what we want to do is now provide a constructor. So we're just going to simply pass in the position and the color that we want. There's the very basic outline for the vertex. I would like this vertex type to actually understand these what these vertex attributes are, so it can send that information to OpenGL. So let's go back to our game class, and the information I want to store is this information down here. Everything that I need to pass into this VertexAttribute pointer function to tell OpenGL what these vertices look like, I want to store that in this vertex type. And so I'm going to make a class up here. I'm going to call this VertexInformation, or we'll just call it VertexInfo. Let's make some public fields here. The first one's going to be the type. Okay, and all we're going to do here is actually store this vertex type, the actual type of this struct. Anytime we have a class or a function that's using this structure, we can always get the type and understand what this is. So next, what I'd like to do is store the size. And this would be the size of this vertex in bytes. So this will end up being 6 floating point values, which are 4 bytes each. So it would be a total of 24 bytes for this vertex position color. So we're going to do that, save that there, and then we have one more thing that I want to store, and that's the actual vertex attribute information. And that's the information that we're going to pass here to the attrib pointer, and that's information like the index, that's the number of components, and that'll be also the offset here on the end. So let's make a vertex attribute struct. So the sole purpose of this vertex attribute struct is just to store this information here. So first thing we need is the index, and I'm going to start bringing this open here. So we need the index and the size is actually the number of components. Okay, so this vertex attribute is just going to store information about the attributes in the vertex. So position is an attribute, and color is an attribute. So this vertex would have two attributes, and we would store information like the index, we would store the number of components. So for instance, in the position attribute, it has 2 floating point components. The color attribute would have 4 floating point components, so that'd be 4. And I also want to store the name. And the name is going to relate to the vertex shader, and that'll be this information right here. So the name of this attribute is a position, and the name of this attribute is a color. And so I'm going to store a string that contains the actual name in the vertex shader. So let's go ahead and write what that's going to look like. So first, let's have a read-only string, and this is going to be name. Again, that's the name of this attribute in the vertex shader. You know, looking at this, I'm not sure if I actually want to store the name, or is this going to be the actual name from the vertex shader attribute, or is this going to be just a descriptive name of what this attribute is? That's something we'll have to decide as maybe we start designing the engine. But for right now, we'll just have a string that's kind of flexible. Right now, this could either be maybe the name in the vertex shader of that attribute, or maybe it's just a name that we want to give it. But I'm just going to leave that field there. As the framework development goes along, we'll probably we'll figure out what that name should actually be. Next, let's go ahead and store the index. And we can go back to our game class. So index is this first field right here. Next is the size, and that's the number of components in this attribute. So that's 1, 2, 3, or 4. Okay, and let's call this I'm going to call this the component count. Okay, the vertex attrib pointer type. Okay, so the vertex attrib pointer type, that's always going to be floating point. Right now, I'm going to make that nice and simple. I'm just going to use floating point for everything, so we'll just specify float. We may want to change that later as we keep developing here, but right now let's keep it simple. Let's make everything a floating point attribute. The next one is the actual size of the vertex. And the size of the vertex can be retrieved from the VertexInfo right here. So we've got that one defined already. And then finally we have this end component, and that's going to be the offset. And that's the number of bytes we have to move inside this vertex to get to this attribute. Okay, so we want to store the offset. Let's go ahead and define that here. Okay, and then we'll just make a constructor so we can populate these fields. All right, and let me just set these real quick. Okay, there we are. So nice and simple, we're just storing the information right here. Let's go back to our VertexInfo, and we're going to make an array. And this is going to be an array of vertex attributes. And actually, I want to make all of these fields in this class read-only, because these are not going to change. Once they're specified, they're always going to stay the same. Okay, there we are. So now we just need a constructor for this. And so I'm going to make a params array where we can just pass in multiple parameters that are vertex attributes. And you'll see what that looks like here in a second. Let me go ahead and just specify that. So we're going to pass in an array of vertex attributes. I'm just going to call that attributes. So now we can totally just send in as many attributes as we want to this array when we're specifying this VertexInfo. So let's go ahead and just set this constructor up real quick. So the type is simply going to be the type. The size in bytes is going to start at 0, and we're just going to start counting up the size in bytes as we go along here. This vertex attributes is going to be equal to attributes, and that's what we're passing in right there. And then I want to loop through all of the attributes that we just passed in. We're going to use these attributes now to calculate the size of this vertex. Okay, so let's go ahead and get the attribute. And the size in bytes is just going to be incremented by the attribute. We're going to get the component count and multiply that by the size of a float. So each component is a float, so we're going to get the number of components in this attribute, multiply it by the size of a floating point value. So that'll give us the actual size of this attribute. And then we'll just add all the size of the attributes together to get the total size in bytes. So that is everything we need there. The final thing is inside our vertex position, I want each vertex type, each one of these structs, to be able to store this information here. So for every vertex, we're going to make a public static read-only VertexInfo. And we're just going to explicitly define it right here. We're just going to create a new VertexInfo. And then we're going to send in the info right here directly. Okay, so every time we create a new vertex, we're just going to make a new public static read-only VertexInfo and specify the information directly right here. And then the information can be reused anytime that we want a new vertex, or anytime we want a new vertex array as well, or vertex buffer. Okay, so the first thing it wants is the actual type. So we'll just use the type of function and use it on the vertex position color. And next we need to specify all of the vertex attributes. So we have two vertex attributes. So let's go ahead and make two of these. And the first thing it wants is the name. You know, right now I'm just going to call this position, and I might rename that later to match our vertex buffer depending on how we want to use this. So right now I'll just call it position, and we'll see how it goes as we continue our development. But the index for this one is going to be at 0, and we can go back to our game class here. So the first one, index is 0, is going to have 3 components. Oh, and actually, we're going to change that because we're designing this for 2 dimensions. So I'm just going to have, instead of 3 components, it's now going to have 2 components. So let's go back to our vertex definition. This one's actually going to have 2 components instead of 3 because we're going to be using a vector 2 instead. And then the offset, this one's just going to be at 0. Okay, the next vertex attribute is going to be the color. Now the index is going to be, the next index is 1. The number of components color has is 4 floating point values for red, green, blue, and alpha, so we're going to put 4 there. And then the offset is just going to be how far we need to advance in this attribute. So we need to advance by 2 because the first one has 2 components in it, but it's 2 times the size of float. So now we have a vertex type, and it knows exactly the information it needs to pass to OpenGL. All right, let's go back to our game class, and before I actually bring in this vertex type, I'm going to change our engine or our framework here to use only 2-dimensional positions. So let's change this to 2 floats, and I'm going to get rid of all the z positions here. So that's going to be the 3rd component in each one of these lines. Okay, so I'm just dropping out the z component. Okay, and so now that we have that, I need to change the VertexAttribute pointer to say that this only has 2 components for the first one, and then the second one, the offset needs to be advanced by 2 as well over here. And then inside our shader code, this is actually going to pass in a vector 2 position instead of vector 3, and I think the actual code inside shouldn't change, yeah, because I'm using the x position there and the y position there. And then I'm just passing in 0 right here when we pass out the GL position. Okay, so that should do it. Let's just run it and make sure it's still working with those vector 2 positions. Oh, and that doesn't look quite right. So there's, let's go ahead and check our code for some settings that I didn't change. Okay, and here's what happened. The actual size of these vertices changed, and I didn't change this line right here. Instead of having 7 components each, we now have 6. We have 2 and 4. So we need to change this to 6. And let's see if that fixed it. Okay, so we're back to exactly where we were before. Now, let's go ahead and go back to our vertex buffer. All right, so here's where we're specifying our vertices. So instead of using this array, let's make an array of vertex position color. So we're going to have a vertex position color array. I'm going to call this vertices as well. Okay, so we're basically doing exactly the same thing we did before, except instead of defining just a bunch of floating point values, we're going to define 4 vertex position colors. So let's do the first one. Whatever this line is right here, I'm just going to put it right in here. So we have a new vector 2, that's going to be x, y plus h, and then a new color. So this will be a color 4, and this will be 1, 0, 0, 1. All right, and I'm just going to copy this. All right, so now we have the 4 vertices. Let's just change this data so it matches our previous data. Okay, so the vertices should, the actual position should be lined up correctly now. Let's change the colors. So the next one is going to be 0, 1, 0, 1. Then we have 0, 0, 1, 1. And then we have 1, 1, 0, 1. Okay, there we are. So I'm going to go ahead and comment out our old code here. And let's make the changes we need to make so this will work. So now inside our vertex buffer, this code is pretty much ready to go. The only problem is when we specify the size of the vertex buffer, we're multiplying the length of the array times the size of float. And this actually needs to be times the size of a vertex or our vertex position color. So we're going to use the vertex position color. We're going to use the VertexInfo, and we're going to get the size in bytes. And actually, let me go ahead and save that value to a local variable. So let's make vertex size in bytes, and I'm just going to bring this over here because we're going to use we're going to use this multiple times. So let me go ahead and put that there, and we'll just multiply this by the vertex size in bytes. So that should take care of the vertex buffer creation. So next we need to actually change the vertex array creation, and this is where it kind of gets really cool. It allows OpenGL to now take care of most of the setup for us. I'm going to go ahead and drop these lines down so I can see them a little bit easier. Let's go ahead and get the vertex attributes. So I'm going to make a vertex attribute. Okay, I'm going to call this attribute 0, and I'm just going to get the vertex attribute from the vertex position color. So we can do that by getting the VertexInfo and the vertex attributes at index 0. So that'll give me the first vertex attribute, and then I can copy that and get the second one as well, index 1, and I just need to change this to index 1 down here. And so really easily we're able to get all the vertex info and the attribute info right there. Okay, and so all I have to do now is go down here and pass in the information. So this would be attribute 0 index. This would be attribute 0 component count. Now we're going to right here pass in the size of the vertex. So this would be vertex size in bytes. And then the last one is the attribute 0, and that'll be the offset. I'm going to delete this second line. And we're just going to copy this and paste the second one in, and then all I have to do is tell the second line that we're using attribute 1, and it will automatically get all the information that it needs. And then when we're enabling the VertexAttribute array here, let's go ahead and pass in the offset. So this will be attribute 0. I'm sorry, not the offset. This will be the index. Okay, so these values should match here. So this index should match this index, and then we'll do the same thing down here for attribute 1, and we'll pass in the index. I think that's all we need to do there. Let's go ahead and run it and see what it looks like. It should look exactly the same. Okay, so there we are. Really cool. It looks exactly the same. We didn't really make any progress in the way it looks, but the way our code is way more flexible now. Let me go ahead and close this, and we'll get back to our code. If you look at what we've done here, this is basically just a for loop. I can now just loop through this attribute array, and then I can just set up this information automatically in the loop. This will make our coding way more simple and give us a lot of flexibility. And anytime we want to create a new vertex, all we have to do is go in here and make this structure again, but with any attributes we want, and then just specify what the attributes look like right here inside the VertexInfo. So right now we've got a huge win for readability. If we go back to our array, it's a lot easier to read this. And then we have a huge win for flexibility as well, and also for the engine itself being able to set up our VertexAttribute pointers, or to set up the vertex array. So what we're going to do next time is simplify our code even more. We're going to take all of these vertex buffers, index buffers, this vertex array, and we're going to wrap them into a class that can be created with just a constructor, and then we have it set, ready to go. So that is how we're going to create our custom vertex formats in OpenGL. And in fact, we can create one more here just so we get the idea of how easy it is that we can do this. So let's create a new structure or a new vertex type. And I'm going to call this vertex position and texture. So this particular vertex will have a position and a texture coordinate. And we haven't really talked about texture coordinates yet, but this will set it up so we're ready to go when we need it. So let's just go ahead and specify the position attribute. And actually these need to be read only. And then we're going to specify the texture coordinate. And I'm going to call this texture coord, and that'll be texture coordinate. Okay, and so this one is actually even smaller. It just has a vector2 for position and vector2 for a texture coordinate. And it's important to keep in mind how many bytes each one of these takes, because that'll tell us in the end how big of a vertex buffer we need to store all this information. Let's create our VertexInfo. All right, so let's simply pass in the type. All right, and then the vertex attributes. So let's call this one position again. This will be starting at 0 index. The number of components is going to be 2 floating point values, and the offset is going to be 0. All right, for the second one, this is going to be a texture coordinate. The index is going to be at 1. The component count, this is going to have 2 in it as well, 2 floating point values. And the offset is going to be 2 times the size of float. So there we are. So you can see how simple it is for us to set up a new texture. Anytime we want a new texture, we just set it up just like this. And the only thing I'm missing is just the constructor, and then we'll be all done. Okay, so there we are. So we have a very flexible and easy way to create vertices. Next time, let's go ahead and set up our vertex buffer, our index buffer, and our vertex array object in a way that's very easy to set up and reuse.